Okay, so part two, we're just going to continue on. And so let's see, I have another one that's fairly similar to the one we just completed. It's kind of the same idea. It's going to have a couple, it's going to have 3x-intercepts. The previous one, you might say it only had two, but it had a multiplicity of two on one of them. So that's where I bounced off. So anyways, all right. So here we are. We need to go ahead and set this equal, um, or set one side to 0. So I'm going to actually, this time, I'm actually going to add x cubed to both sides. And in doing so, I'm going to 0 out the left side. So 0 is less than, let's see, x cubed um, minus 6x squared, and then minus 40x. And I just kind of, as a habit, I like to kind of have my polynomial on the left side of the inequality. So you kind of have to be careful. So right now it says 0 is less than my polynomial, right? Or it's also saying that my polynomial x cubed minus 6x minus 40x is greater than 0. So I'm going to flip that around because you got to be able to read it both directions. And so this is what it says. If I want to flip the two sides, I have to actually flip the inequality sign also. And so you don't have to do that, but I just kind of like to be consistent. If they've been on the left side, I want to kind of continue to keep it on the left side. Okay, so now it's time to factor this to find the x-intercepts. And so I can start by factoring out an x. Oops, I forgot my squared there. We'll start by factoring out an x. So let's see, that'll leave me with x squared minus 6x minus 40 is greater than 0. And then let's see, I'm going to figure out what multiplies to give me negative 40, but add to negative 6. I believe that's going to be, what, a minus 10 and a plus 4. Those two numbers multiply to give me negative 40, and they add to give me negative 6. And so um, now I'm going to list my x-intercepts. My x-intercepts, let's see, would be a 0, a 10, and negative 4. Those are the three values that would cause the left side to go to 0. Those are my three x-intercepts. And let's see, are those true though? If I plug them in, does it create my inequality? Does it create a true statement? And it does not, because 0 is not greater than 0. So these, um, my x-intercepts will not be part of my solution set. But I need to go ahead and put these numbers on my number line. So let's see, we'll go in numerical order. So let's see, we'll have negative 4 here, I'll put 0 here, and I'll put 10 here. And, I'm not spacing it, you know, it doesn't have to be to scale, but anyways. So I know that those come back false, so I'm going to put open circles at all those values right there. But now I need to test the sub intervals on this. I need to test the sub intervals. And so let's see, for this first spot between negative infinity and 4, we'll probably just test negative 5. That'd be pretty simple. And then let's see, for my next one, I'd probably just test negative 1, try to keep my number small. And then on the other side of the 0, let's see, we'll probably test positive 1. And then over here, going towards infinity, let's see, we'll probably test 11. Sounds good. So we'll test those values. Okay, Um, so now I need to plug in those tested values and test it. So I'm going to take this expression right here and um, plug it into there. And so once again, I'm going to probably do a lot of this math in my head because I'm not going to have a lot of space. So let's see, my first value is negative 5, so that's fine. And then let's see, negative 5, take away 10. Let's see, that would be negative 15. And then let's see, negative 5 plus 4, let's see, that's negative 1, and then greater than 0. All right, so if we multiply this all together, let's see, negative times a negative, let's see, that would give me positive 75, and then times negative 1 be negative 75 is greater than 0. Negative 75 greater than 0? Nope, that would be false, so we don't want to shade there. All right. let's try -1. So let's see, we plug in -1. Let's see, so we're going to have a -1, and then let's see, -1 minus 10, that's going to be -11. And then let's see, -1 plus 4 would be a +3. And then is that greater than 0? That's what we're trying to figure out. Well, when we multiply this together, we're going to get +11, and then times 3, which would be +33, is greater than 0. And that is true. So that is true. So we'll go ahead and shade that subinterval right there. Okay, let's try +1 now. So let's see, +1 times, let's see, 1 minus 10 would be a -9. And then let's see, 1 plus 4 would be a 5. And then is that greater than 0? Well, let's see. Multiply the first two together. That gives me -9 times 5 would be -45. Is -45 greater than 0? No, negative numbers are not greater than 0, so that's going to come back as false, and so we're not going to shade that part. And then my last one, let's see, we're going to plug in 11. So let's see, we're going to have 11 times, let's see, 11 minus 10 would be 1. And then 11 plus 4 would be 15. Is that greater than 0? All right, well, let's see. When we multiply that all together, we're going to get a positive number. Let's see, what is that? I think it's 165. Yeah, 165 is greater than 0. Yep, that's true. True. And so we'll go ahead and shade that part of it. And then now we need to go ahead and put this with our interval notation. So the first part of it, and we got to remember those are not included. So from -4 to 0, but we're going to use parentheses to indicate we don't include the endpoints. And then we have to union in and go from 10 to infinity. And there we are. Okay, so that's going to conclude the polynomial part of this lesson. And so it was hopefully not too bad. You find the x-intercepts, and then you have to test those points between them. Now we're going to move to the rational inequalities, and it's going to be similar but a little different. Okay, so I have kind of this procedure for that down here. So, okay. So rational inequalities, we just got done graphing those, so we should hopefully be kind of familiar with those. So the procedures for solving rational inequalities is a little bit trickier, but it's very similar kind of process. So our step one is to find the x-intercept of the graph by setting the numerator equal to 0 in solving. And so we've done that before. So you set the numerator equal to 0 to find the x-intercept. Now this is important. Note, this value may or may not be part of the solution set, okay? Because that's dependent upon the inequality. Just kind of like we saw previously with the polynomials, if it doesn't have the equals to part, then the x-intercepts are not included because 0 is not greater than 0. But if you throw in the equals to underneath it, all of a sudden they are included, right? Now I'm going to go ahead and erase that. But so that's kind of the deal with x-intercepts is sometimes they're included, sometimes they're not. Now this next part, you're going to find the excluded domain value by setting the denominator equal to 0 in solving. So you're basically finding the vertical asymptote. You're finding the vertical asymptote if you're kind of thinking of the graph. Note, this is excluded and can never be part of the solution set because it's the undefined value. It's the value that if you plug it in, actually comes back as undefined. So you find the x-intercept may or may not be included by setting the numerator equal to 0. Then you find the excluded domain value. Essentially, you're finding the vertical asymptote by setting the denominator equal to 0. That cannot be part of my set. So then step 3, this should be familiar. You're going to plot the points from step 1 and 2 and then test values within the sub-intervals. Okay, so let's go ahead and jump in. And then on this first one, once again, I actually do give you a picture. Okay, you won't always have the picture, but it kind of helps you visualize what's taking place. So we have this expression right here, 3x over x plus 6 is less than 0. And so you can already see that this is the solution right there on the graph, because all those values are less than 0, right? But we're going to, obviously we're going to kind of follow those procedures so we can kind of see this, because we won't always have the picture. So step 1 is find the x-intercept by setting the numerator equal to 0. So we take 3x, set that equal to 0, and solve. Divide by 3 on both sides, and so we get x equals 0. So that's my x-intercept. Is it included? No. False. Because if you plug that in, you'll get 0 is less than 0, which is false. 0 is not less than 0, right? So that would be false. Then next, you're going to find the excluded value of the domain, which is essentially, and I like to point this out to help you remember this is never included. It's the vertical asymptote, because that point doesn't even, there isn't a point. It's actually, it's a value that creates your vertical asymptote. And what it does, with the reason this is a key value is because typically, not always, but typically at your vertical asymptote, your rational function either goes up positively or goes down negatively. And so see, there's a sign change when you cross the vertical asymptote. Just like when you cross the x-axis, obviously, if you cross the x-axis, you're going to have a sign change, right? If you cross it, you go, in this case, go from negative to positive. In this case, I cross my vertical asymptote from being a positive to being a negative. And so that's why that's another key point of these rational inequalities. So in order to find this, you take the denominator, and I'm going to put that in the notes, you take the denominator and set that equal to 0. So we're going to take x plus 6 and set that equal to 0, and then subtract 6 from both sides. And so we end up getting x equals negative 6. And then that will never be included. So let's go ahead and plot these values on here. So let's see, I'm going to have negative 6 here, and I can put 0 here. And they're both going to be open circles in this case. Both open circles. Okay, so then I am going to need to test some points. And when we test it, we'll just plug it back into that original one because we didn't factor it. Okay, so let's see. We'll test like x equals negative 7. Let's see, we can test x equals negative 1, and then we could test positive 1. Okay, and so we're going to go ahead and plug that in. So let's see, when we plug that in, we're going to get 3 times negative 7 divided by negative 7 plus 6. And then we want to figure out, is that less than 0? Well, let's kind of clean this up a little bit, and I'll probably be able to tell pretty easily. So let's see. 3 times negative 7 is negative 21. And then on bottom, negative 7 plus 6 is negative 1. Is that greater than 0? Yes, it is, because a negative divided by a negative is positive. Oh, I'm sorry. No, it's not true. It's false. Sorry about that. A negative times a negative is positive, which is positive 21, which is not less than 0. 21 is not less than 0, so that is going to be false. So we are not going to shade that part. Okay, let's try negative 1 now. So let's see, we're going to have 3 times negative 1 over negative 1 plus 6. Is that less than 0? Well, let's see. I'm going to give myself a little bit more space. All right, so let's see. So that would give me negative 3 over, what is that, positive 5. And so that is a negative ratio right there. That's a negative number. The negative doesn't cancel out because it only have a single negative. So negative numbers are less than 0. So that's going to come back as true. So we'll go ahead and shade between those right there. Okay. Now let's try positive 1. So let's see, we're going to have 3 times 1 divided by 1 plus 6. Is that less than 0? Is that less than 0? Well, let's see. 3 times 1 is 3. 1 plus 6 is 7. That's a positive number. 3 over 7 is a positive number. Positive numbers are not less than 0, so that is going to be false. Okay, so my interval notation is going to be numbers between -6 and 0, but not including them, so that's why we have to put those parentheses. All right, one slide left. Here we are, and I've only got 2 of them. Okay, here we are. So this one, we're going to do the same thing we did on the last one. So first thing you have to find in the procedures, if you look back, is find the x-intercepts. And so to do that, you're going to set the numerator equal to 0. So we're going to get x minus 4 equals 0. And let's see, we're going to add 4 to both sides. And so we're going to get x equals 4. Now, this may or may not be part of my solution set. In this case, it is. So this is true because when I plug this in, I'll get 0 is greater than or equal to 0, which is true. Because if I plug in 4, it causes the left side to go to 0, and 0 is greater than or equal to 0. So we will include 4. It's part of my solution set. Okay, the next part is basically you're finding the vertical asymptote, right? And the way we find that is we take the denominator and set that equal to 0. So we're going to take x plus 3 and set that equal to 0 and solve. So we subtract 3 from both sides. And so we get x equals -3. Now, that one can never be included, okay, because that's an undefined value. It makes it undefined. So let's see, we're going to plot -3, and we'll plot 4 over here. So in this case, like I said, the vertical asymptote or the restricted value cannot be included, so that'll be an open circle. And then 4, in this case, it will be included, the x-intercept. Okay, so next, it's time to test some values. So let's see. Once again, just pick some easy ones. So like -4. Looks like 0 is available. That's always an easy one to test. And then, let's see, probably like 5 over here would be good. All right, so let's go ahead and do it. So let's see, we're going to plug in -4. So let's see, we're going to get -4 minus 4 over -4 plus 3. Is that greater than or equal to 0? Well, let's see what happens here. On top, I'm going to end up with a -8 over -1 is greater than or equal to 0. So a negative divided by a negative is positive. And so, yeah, 8 is greater than or equal to 0, so that's going to come back as true. So we'll go ahead and shade that part of it. And then the next one we want to try is 0. So let's see, we're going to have 0 minus 4 over 0 plus 3. Is that greater than or equal to 0? And so let's see, we're going to end up with -4 over 3 is greater than or equal to 0. Well, that's a negative ratio. That's a negative value. Negative values are not greater than or equal to 0, so that is going to be false. And then now, let's see, now we need to test 5. So let's see, we're going to have 5 minus 4 over 5 plus 3. Is that greater than or equal to 0? Well, let's see, 5 minus 4 is 1. 5 plus 3 is 8. So 1 over 8 is a pretty small number, but it's still greater than or equal to 0, so that is true. So we're going to include all those points here. And let's see, so now we need to put this up as an interval notation. So my first interval is going to be from -infinity to 3, and I'm going to parentheses that in. And then union Then we're going to bracket the 4 and then to positive infinity like that. Okay, so I have one left here for us. And so the difference on this last one is the algebra is going to be a little trickier. All right. So kind of hang in here with me on this first part. It's just we got to clean it up a little bit. We don't want that 2 there. And so it kind of depends on how much you kind of remember from some of your basic algebra here. And I say basic, but I know fractions students are never really big fans. But this is something you would have probably learned a while ago. Um, and I don't blame you if you've kind of forgot some of it. But what we want to do here is we want to set this, the right side, we want that to be a 0. So I'm going to start by subtracting 2 from both sides. So I'm going to have x plus 1 over x plus 3, and then minus 2 is less than 0. So what I'm going to have to do here is I can't leave it like this. I have to have a single fraction because right now my x-intercept is not -1. Because if I plug in -1, sure, it would make this equal 0, but the whole side would not be 0 to where I would not be really, that wouldn't be very helpful. So that's not the x-intercept. So in order to do that, what I have to do here is I have to bring this together as a single fraction. And so basically, I'm going to have to get a common denominator. And so my denominator that I have on the first one is x plus 3. So that actually is going to be my LCD is going to be x plus 3. So what I'm going to do here is I'm going to kind of manipulate my 2 right here. I'm going to rewrite this, and then I'm going to kind of I'll color code this so we can kind of see what's going on here. What I'm going to do is I'm going to change that minus 2 into a minus 2 times x plus 3 over x plus 3. So I'm, once again, a lot of things in math is just about kind of manipulating things. And that's what I'm doing here. I manipulated this to where I have a common denominator. You have to have a common denominator in order to add and subtract fractions. Let me go ahead and put that rule down. Basically, if you have a over d, or see, a over d plus b over d, or it could be minus or whatever. You have to have a common denominator, and then you bring the numerators together and do whatever that operation is, whether it's addition or subtraction, over that common denominator. So what I'm going to do here is I can rewrite this as x plus 1 minus 2 times x plus 3 all over my common denominator of x plus 3. Okay, so once again, like I said, if you haven't seen this in a while, I get it. Um, Hopefully you're recalling some of these rules, but basically I had to have this common denominator. So basically multiplied that 2 by x plus 3 over x plus 3, because this is the same thing as 2. Because I don't want to do this, but if I were to cancel those out, I'd be right back to where I was. But I manipulated it to where I could bring this together, and so now I'm going to go ahead and finish simplifying this. And so the next step would be to distribute that minus 2. So let's see, we're going to have an x plus 1 minus 2x minus 6. Be careful, you got to distribute that minus 2 to both parts. All over x plus 3 is less than 0. And then let's see, then next we just need to combine our like terms. So let's see, x minus 2x would be a negative 1x, and then plus 1 minus 6 would be, what is that? Let's see, that'd be a minus 5, and then all over my x plus 3. And now we're ready to start, right? Feels like we should be done, but we're actually just now ready to start the problem. So if you recall, the key points that we need to find are the x-intercept by setting the numerator equal to 0, and I'm going to do that. Let's see, I'm going to do that kind of up over here. So for my x-intercept, let's see, we set the numerator equal, numerator equal to 0, and then, so let's see, so negative x minus 5 equals 0. And the easiest thing to do here probably would be to add an x to both sides. And so I'll figure out that negative 5 equals x. So that is my x-intercept right there. So I took the numerator and set it equal to 0. Now when I plug it in, I would get 0 is less than 0, which is false. So it's still a key point, but it will not be included as part of my solution. Then next, I need to find the vertical asymptote value, basically the restricted value, by taking the denominator and setting that equal to 0. So we're going to take x plus 3, set that equal to 0, and solve. And so let's see, I'm going to subtract 3 from both sides. So I'm going to get x equals -3, and then that value is never included because it actually causes it to be undefined. But it is a key point of the graph, and so that's one of our key points that we put on our number line. So now I'm ready to kind of go back up and start plugging in those values. Um, Now I do want to probably use this when I test it. I probably want to use this equation, our inequality, when I test it, because the other one would just, it's a little bit more difficult to tell, and I'll explain why when I kind of come up here. So we want to test the values of -3. Oh no, I got to go in order, numerical order. -5 and -3. Now we know they're both not included, so I'm going to put open circles. Now, you could test it in the original if you want, but it just might be a little bit harder to tell if it's less than 2 because we might be getting fractions in return. And I mean, you can plug it in the calculator and that's fine. It's not really that big of a deal. If you want to plug it into the original, you can. But plugging it into the one down here, it'll be a little bit more clear whether it's true or false. So that's the one I'm probably going to use is down here. So let's see, let's pick our values that we're going to test. We're going to test x equals -6. Let's see, we test x equals -4. And then here I'm going to pick 0 because 0 is always something easy to test. Okay, so I don't have a lot of room to work with. So I'm going to do some of this algebra in my head just so I can fit it all on the same page so we can see it all at once. So I'm going to plug these values in, and like I said, I'm going to plug it into the one down here. You could plug it into the original, that'd be fine too. But I'm going to plug it in down here. So I'm going to have a -6. So the double negative will turn that to a +6 -4. So I end up with, I'm sorry, -5, which I will end up with a +1 on my numerator spot. Okay, so negative negative becomes positive. +6 minus 5 is 1. Then -6 plus 3 is a -3. And then we're trying to figure out, is this less than 0? Well, yeah, it's a negative value, right? 1 over -3 is a negative number. Negative numbers are less than 0, so this is going to come back as true. So that first part is true. Now let's try -4. So let's see, -4 becomes +4. +4 take away 5 would leave me with a -1 in the numerator spot. Then let's see, -4 plus a +3 would be a -1. Is that less than 0? Well, double negatives turn positive, and +1 is less than 0. Nope, that would be false. So we're not going to shade that part of it. And then my last one that I want to test is 0. So -0, which just is 0. 0 take away 5 would be -5 as my numerator spot. And then 0 plus 3, well, 0 plus 3 is 3. Is that less than 0? Well, it's a negative ratio, which is a negative number. Negative numbers are less than 0, so that's going to come back as true. So I want to go ahead and shade that part of it. And then the last thing I need to do is go ahead and put this in my interval notation. So the first one's going to be from -infinity to -5. okay, parentheses. Then we have to union in the other part of it, which is going to be from -3 to infinity. And there we are. There you have it. Okay, so hopefully y'all are good to go. And so we're going to stop here. I'm not going to start chapter 4 yet. We'll just hold off on that. We'll deal with that next week. We do have our test Monday, so focus on the review. If you get hung up on some of that over the weekend, you can email me and ask for some help. And then we'll still have that first 20 minutes on Monday to kind of answer any last minute questions. So anyways, hang in there. Um, and like I said, don't hesitate to shoot me an email if you have any questions.